everyone. Welcome back to the FDP. We'll start the session. I request Dr. Ajit Kumar Behera sir to kindly start with the session.
Okay, Deepak. Okay, let's start. Am I audible?
Yes, sir.
Slides are visible?
Yes, sir. It's visible, sir.
Okay. So, in previous session, I discussed about that groundwater. So, this session is about groundwater modeling. Though I don't have much idea about AI and machine learning, but this session probably it will be better if we have some interaction with the PhD scholar and how they want to do groundwater modeling through AI, or what type of output generally we get through this groundwater modeling. So we'll discuss. Okay. So groundwater modeling, it is basically a mathematical model that simulates the groundwater flow indirectly by means of a governing equation that thought to present the physical process that occur in the system together with equations that describe heads and flows along the boundaries of the model. So basically in groundwater model, what we do, we use some equation, mathematical equation, and try to study the real uh, field situation, and what are the different variables they generally react by inputting the variables or parameters. So we generally study through this groundwater modeling. So basically we need, as I have already told, so we have this system. This system is basically aquifer system, and aquifer system means we should have some parameters. So these parameters, or these aquifer parameters, are transmissibility, storativity, porosity, permeability. These are aquifer parameters we required before developing some model. Then so how do we acquire this parameter? By doing pumping test, as I discussed. Through pumping test we can collect this parameter, that is discharge, transmissibility, hydraulic conductivity. And this pumping well, particularly when we do some pumping well in aquifer system, we can tap the aquifer parameters for a particular location or particular point. Okay. So first process is, after collecting all these parameters, first part is to develop one conceptual model. So here you can see this is the field study. What we have seen in field, we have different geological units or litho units, or we can say from this geological formation or lithological units, we try to develop one 3D model where we can get some aquifer, or we can say some hydrostatic stratigraphy unit. So in hydrostratigraphy unit, we should have some aquifer, some aquitard or aquiclude. So there is a system, there is a aquifer system, or in this aquifer system, these aquifer are all, we have alternate aquifer and aquitard. So from field parameters or field observation, we try to develop some conceptual model. Then after this conceptual model, we prepare on a groundwater flow model by using some software. Here we have used visual mode flow. Visual mode flow basically, we in visual mode flow we use finite difference method. So the here you can see this is the geological model. In geological model, we have water table, then silty sand, sand and shale. So we have three different layers. So now what to do? In conceptual model, we have to characterize its parameter like hydraulic conductivity. What means this is this is silty sand. So hydraulic conductivity here we have kept 1. This may be meter per second, maybe centimeter per second or meter per day. And as this is the sand top shell or base of aquifer, so maybe sand. So sand has high hydraulic conductivity. This may be 10 meter per day. So after this, then we run the model or give some boundary condition, some initial head value, then run the model and it comes like that. So these are the different hydraulic head values. So based on this hydraulic head value, we can identify the flow direction. Here it is showing that H is 90, then 80. So higher, this is the high hydraulic head, this is the low hydraulic head. So groundwater flow direction is from this direction. Okay. So this is the case study. So this is the case study. So I have taken the study area. It is coastal district in Odisha. This is Jagatsinghpur coastal district in Odisha. Okay, and it is a part of Mahanadi Delta. So this Mahanadi Delta again classified into two different formation, that is upper delta formation and lower delta formation. So low delta formation basically we have clay with fine sand, and upper delta formation that is sandy silt, silty clay. So these are the different two. These are two different formation based on its litho units. And this deltaic formation is bounded by Mahanadi River, Devi River. Okay, and it is also we have Bay of Bengal. Uh, um, that can, so basically we try to model this total coastal aquifer system of this Jagatsinghpur area. So here we have only consider shallow aquifer whose thickness is less than 50 meter. We can also model the deeper aquifer, but due to unavailability of data, we actually could not model the deeper aquifer. So here we have only focused on shallow aquifer only. Then, then data acquisition. So what type of data we generally need means we want to do this model, that is rainfall data, observation well or hydraulic head data, borehole data and aquifer parameters. So here we can say these are the different lithologs. So here in different locations, so we have different lithologs, depth wise lithologs are there. So based on these lithologs, we prepare some hydrostratigraphy units. So these hydrostratigraphy unit are nothing. These are the you can say these are the aquifer system. In aquifer system, we have first unconfined aquifer, that is the topmost aquifer. Then below this unconfined aquifer, we have acute tad, as I discussed in previous session. So alternate we have aquifers and acute tad. Okay, this is also known as fence diagram. So this fence diagram gives you one conceptual. From this fence diagram, we try to develop one conceptual model. So this is the conceptual model. In conceptual model, we have taken, this is the shallow top aquifer, unconfined aquifer. In this unconfined aquifer, we have constant head boundary. So we'll discuss in later what is constant head boundary. Then in base there is no flow boundary, because it is acute, so we have kept this no flow boundary. That means further flow, there is no flow between this unconfined aquifer and below this no flow boundary condition. So these are the general equation we use for simulation of groundwater flow model. So in steady state condition, we don't depend on the time. So that's why the equation is here. There is no time limit. But in transient state condition, we simulate the groundwater flow model in day wise or monthly wise. This is basically time dependent flow model. Okay, so in so this is I have used to develop this groundwater model visual mode flow. So I have already told you that I have used visual mode flow, one of the groundwater modeling software. So in that groundwater modeling software, this is the area. We have discretized this area several grids or cells. So here we have different type of we have total, this is the number of cells. We have discretized this study area, and each grid is 6 meter into 6 meter square block, and the thickness of this aquifer system we have kept, and that is varies from 30 meter to 50 meter. So inactive cell means these are the inactive cells. That means we have kept this model domain, this area no flow condition, means there is we have kept this area as a no flow condition. In active cell, we have kept this area flow condition. So basically our objective to study this area, so we have kept this active cell. These are the different observation well. From these observation well, uh, what we try to find out that these observation wells gives us the initial head value or hydraulic head value. And this model domain is bounded by two type of boundary condition. One is river boundary condition, another is constant head boundary condition. So constant head boundary condition, Bay of Bengal, we have kept constant head boundary condition. That means through this line we have constant head, means there is no change in hydraulic head value. Okay, in river boundary condition, that is changes due to the changes in hydraulic head in observation well. So this flux in river, that generally changes. So according to time or rainfall, so that generally varies from time to time. Then we have three different zone, and that is based on the hydraulic conductivity and specific yield. So now we are using the aquifer parameters here. So we have classified this domain into three zone. One is zone 1, zone 2, zone 3, based on the hydraulic conductivity parameters and specific yield parameters. Once again, this model domain we have classified in several zones. These zones are known as recharge zones. So these recharge zones are basically we based on rainfall data. So in different zone we have different rainfall. So in different rainfall means different recharge is taking place within this aquifer system. So based on this different recharge parameters, then we try to do the simulation of groundwater flow model. These are the summary of parameters. What parameters we have taken for this modeling study. Okay. So after this, basically this is the common thing. I think most of you are using this type of correlation type of study where we calibrate the model, where we try to match the observer head with a calculate head to know the how model means how model is working or properly or not. So this is the steady state condition. In steady state, here we don't have any time limit. Here we have considered for 1 day, so it is coming like that. When we model for transient state, so variation, so there is the hydraulic head variation. You can see the variation in hydraulic head. So that is almost matching. So based on these parameters, then we process further. So after this, we try to see the different observation well. What is the hydraulic head condition in different observation well? So here we have taken 2004, 5, 6, 7. So 4 year data. In 4 year data, we found that this observation well is the hydraulic head of individual observation well. These observation wells, observation well 2, observation well 7, and observation well 10. We have 11 observation well, but here I have taken only 3 observation well based on the location. So observation 10, it is very close to the sea or close to the Bay of Bengal or coastline. Then observation well 7, it is away from the sea. It is we can say that it is intermediate zone of the model area. And observation well 2, it is far away from the sea coast. So here we can see how hydraulic head varies from observation well 2 to 7, then 10. So close to the sea, we have less hydraulic head. The hydraulic head is very less. Away from the sea, we have hydraulic head is more. So that means the flow direction is from observation well towards observation well 7, then 10, then to the sea coast or sea line, seashore line. Similarly, validation also, it is showing that the observation head is matching with the simulated head or calculated head. So then after that, we so this is our objective. So this is our objective means to identify the different means we have given different recharge. We have different recharge zones, and how this recharge zones react when there is rainfall occurs, when we extract some groundwater. So here you can see this is the monthly rainfall, and in zone 2, that is the away from the coastline. In zone 2, we have rainfall. So this is showing a recharge line, or you can say this is net recharge. That means due to rainfall, some recharge takes place that goes below the earth surface and try to recharge the groundwater. But when we extract some groundwater for our agricultural activity or for household purposes, then we minus that recharge groundwater from this extracting groundwater. So that is net recharge. So net recharge basically how much water goes below to the below to how much water goes below the earth surface and recharge the groundwater zones, and from groundwater zone how much water we are taking out. So we minus that, that is the net recharge. Of course, rainfall is not only the recharge source. We have different recharge source, that canal or surface water or river. These are the different, they may act also different recharge sources. So here you can see in zone 2, so the recharge is the net recharge means we have positive recharge. Positive recharge means we can say in that zone we have groundwater potential is high. And when we calculate this monthly recharge by the monthly rainfall data, so it is showing that after certain times, uh, this recharge, there is no further recharge takes place. So that means we have in aquifer system we have certain capacity. So after that capacity, they don't means if continuous rainfall will occur, so there is no further recharge will takes place. So you sometimes you may aware of this thing, that is waterlog condition. So this waterlog condition basically happens due to this thing, means when there is no further recharge takes place, and the pore spaces are filled with water, and no recharge takes place, and there is no path to take this surplus water to the channel or any sewage canal, then waterlogged condition happens. In case of zone 2, zone 10, which is very close to seashore, in that case what happens, we have a negative recharge. You see, this is the net monthly net recharge is negative, means we are extracting, or we are the withdrawal of groundwater is more rather than recharge. So that's why the negative recharge is there. And here also you can see the rainfall after certain, if continuous rainfall will happen, so we say that the intensity of rainfall is means continuous. So then there is also same thing happen. So after certain time, certain recharge, there is no further recharge takes place. It means here one thing is that the recharge is less. Here the recharge is high, because as I told you, this upper delta formation, this is upper delta formation, and this is lower delta formation. Lower delta formation, we have more clay. So more clay means there is no pores, means we have pore spaces, but there is no interconnected pore spaces. So that's why further recharge, there is no further recharge takes place. So similar results also we generally we get in during validation of this recharge zones. So almost same, means here also you will find the recharge up to 18 monthly, and so this is the period of 2008-9, and when you go to 2004 to 7, that is also 18 of monthly recharge generally uh, takes place during this period. Okay, and due to same similar thing also here also we get the same result. So then we calculate the volumetric budget or recharge. So that means after calculating all these things, now we want to quantify the groundwater resources or recharge resources. How much recharge is basically taking place within this time period? How much groundwater resources we have, and how this aquifer system is basically affected by the presence of sea or constant head boundary, and and how rainfall influence the groundwater condition, here we have mentioned. So first in 2006, this line, it is recharge line. So in recharge line, we have high recharge. So here we have days. So in India, one, you consider it as a January 1st, then 365, 365 day means it is December 31st. So within these ranges we have pre-monsoon period, monsoon period, and post-monsoon period. Pre-monsoon period means that when there is no rainfall, monsoon when there is rainfall, and post-monsoon after a monsoon period, that is considered as post-monsoon. So here what happens? You see this inflow from constant head boundary, outflow from constant head boundary. So inflow is more. Inflow is more means there is no rainfall, and we are extracting more groundwater. Okay. So when there is rainfall, so recharge takes place. Recharge line goes up. Here you can see around 68 million cubic meter recharge takes place within this monsoon time period. Then, as when there is no rainfall, then gradually the recharge uh, decreases. So it is a continuous, means it is a continuous process. When there is a rainfall, recharge takes place. When there is no rainfall, so discharge or heavily extraction of groundwater takes place. It is the basics or fundamental thing in the aquifer system. So in coastal aquifer system, due to this activity, it influenced by the sea. So here you can see, when there is no rainfall, so it is affected by sea. So means there is chances of seawater intrusion into the aquifer system. When there is rainfall, so recharges takes place. So some amount of groundwater that discharge into sea. So it shows that the dynamics between the aquifer system and the sea. So how sea is means aquifer system is affected by the sea. So similar cases we have we found in 2007, 2008, and 2009. So 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 this is the system. This is the hydraulic head variation. How after this, how hydraulic head varies from monthly. So in one day we have hydraulic head. Here you see this is less affected. When pre-monsoon, it is affected by the sea. Here also you see the influence of sea. When monsoon takes place, then it means comes to its original condition, and some groundwater discharge also takes place to the sea. So this is basically showing how our aquifer, shallow coastal aquifer system is affected or react due to the rainfall, or when there is no rainfall, how it is affected by the sea. So key finding is that the zone-wise recharge distribution reveals that the zone near the coast received less recharge as compared to the zones away from the Bay of Bengal. As I told you, the zone 1, zone 2, which are away from the coast, it has a high recharge, and zone 10, which is very close to sea, it has low recharge. Then we have estimated the recharge. So the annual, this is the annual recharge. This net groundwater recharge to this coastal aquifer system is varies from 247.89 to 262.63 million cubic meter. So depletion in hydraulic head due to pumping in coastal aquifer system may result seawater ingress. So if suppose if we don't have rainfall and we extracting more groundwater, then there is a chance of seawater intrusion into the aquifer system. So if we have rainfall and it recharge the aquifer system, then this dynamic process goes on in a time series, or in pre-monsoon there is when sea ingress is there, in monsoon period, that is discharge from coastal aquifer to sea is there. Then comes to application of AI. So here what happened, this groundwater flow model, we use very limited data, but we gather number of information, means hydraulic parameters, hydraulic head, rainfall data, then boundary condition, then river stages value, hydraulic conductance of river. So different, we collect different parameters and we study the field area by, and we collect some samples. We analyze these samples to know the hydrochemical process or hydrogeochemical process. So based on all these information, then we prepare conceptual model. But in case of you can see how AI now, artificial intelligence, how it most of the, you can see it is a growing subject, you can say. number of researchers they want to predict or forecast the groundwater level in different regions. So in Iran basically it is arid climate. So arid climate means here this depletion of groundwater level is high. So similarly China, India, so these are the countries they mainly use artificial intelligence to predict the groundwater level or forecast the groundwater level. And they have large number of papers compared to UK and other countries. So what are the different parameters, input parameters we use? That is groundwater level, precipitation, that is rainfall, temperature, river discharge, evapotranspiration, surface water level, pumping rate, humidity, and this thing. So all these parameters we basically we need to predict the groundwater level or forecast the groundwater level through artificial intelligence. So how this artificial or basically we use artificial neural network. So here I have already discussed that groundwater level, precipitation, temperature, and discharge data we require to model or forecast or predict the groundwater level. So this is the output groundwater level. So these are the different process. Through this process we have to take certain area, like I had taken my study area as a coastal aquifer. So we have to take some study area, and in that study area we have to implement uh, these uh, uh, these features and try to model for future scenario or future condition of groundwater in this in a particular aquifer system. Okay, so this is so like I told you, means the basic is same. Basic is same means we have to identify the percentage of error. If percentage of error is less, then it is very good, and we have to process further. So and we have to prepare our future groundwater model of, or we can forecast our model, or we can also predict some scenarios or condition based on this groundwater level or rainfall data. So these are the various uh, artificial neural network structures used to predict the groundwater level. So, so application of AI, how application of AI is now is a concerning thing for data science scientist or researcher. So from 2008 to 2020, you see the number of papers exponentially growth. So you can see, or you can also means of course you are also looking for this type of work for your study, or you can also predict this groundwater level and contribute the society to manage the groundwater scenarios or condition, or we can also predict the groundwater condition nearby future, or and we can also manage the groundwater with a sustainable development. Thank you.
Thank you, sir. Now I
Uh,
request participants,
yes.
if you have any question, you can ask. Hey, participants, if you have any question, you can unmute yourself and ask the question. Yeah, so well. Excuse me, sir. Am I audible?
Yes.
Sir, you shown some images for collecting data. So
Yes.
for collecting data from well, what type of data logger equipment is used? Is it required or manual information we are collecting?
Uh, Actually, means we have means you want to predict this groundwater level or forecasting groundwater level or anything else. You want to predict or this groundwater flow model. You want to develop some groundwater flow model. So then we have to collect some data. So we have various agencies like CGWB and other agency you can collect lift irrigation department. So from there you can collect the data, but for validation you need to tap this water level, because we don't know actually. So that is one problem, means sometimes we use the collected data, and these collected data basically agency how accurately they measure this water level we don't know. So after developing one model, we can measure one all these observation well data and validate this data. So for that we need some water level indicator instrument, small type of instrument, um, or you can if you want to measure deeper depth aquifer. So deeper depth it is not possible. Basically we go for dog wells as a observation well, and from dog wells we can take this water level data by using water level indicator, small instrument. It is a very small instrument. And aquifer parameters, these are actually you can also get these aquifer parameters from CGWB also.
So these aquifer parameters are common for all the region. It's very based upon the
No,
region.
no, it varies. As I told you, for coastal aquifer, the hydraulic conductivity specific yield will be different. And for hard rock region, like in Chhattisgarh, your region, it is hard rock region, hard rock terrain. So there, your aquifer parameters will be different. But in coastal, their aquifer parameters will be different. One more thing is that in Chhattisgarh region, it is hard rock and very complex hydrogeology. So complex hydrogeology means fractures will be there, and maybe some other means maybe dikes, maybe other some geological parameters will be there. So you don't know whether this is aquifer or aquiclude or aquitad. But in case of coastal aquifer, the formation or formation is almost same. So so basically people means use coastal aquifers to do such type of model. In hard rock also it is possible, but provided you have to give a lot of information and accurate information. I am talking about accurate. Model can be done, means yes, it is can be done this thing. But before doing model, we have to understand the field condition situation. For this, we need to study or visit the field and see or observe the different scenarios or condition on the field. Okay.
But you see that Chhattisgarh region is having a hard rock water.
Yeah.
It is suggested to use water for drinking,
No, no.
such
Actually,
areas water, or
no.
it's not suggested.
This is basically quality wise. So hard rock means the rock is very consolidated. Means you cannot break or the compact or compactness is more in Chhattisgarh. Hard rock. So this is one type of rock type, means igneous rock or metamorphic rock. These are the different geological units. Okay. So you are talking about hard rock, means hard water. We have to see its quality, whether it has some other means hydrochemical parameters like sodium, magnesium, calcium. These are the elements which can tell you about the hardness of groundwater. Okay.
Sir, suppose if we have to dig any well,
Okay.
And for a pumping well, how to decide a area? Like hydraulic pressure is to be identified, or aquatic parameters is to be required to make a
Mm.
proper decision, so that we will get a water without any pump. You have shown image like proper
Ah,
water
so
without pump.
so you basically you are looking for attenuation means auto flow condition, right? Auto flow condition of aquifer. So these are very rarest thing. Means sometimes we uh, actually in Talcher coalfield we got some auto flow condition. We have to see. Means the conditions, the surrounding condition means whether this is in confined condition. So preliminary survey is what we do remote sensing study, and then followed by some geophysical study, geophysical resistivity study. So based on this study we try to collect the information about this aquifer, whether this can be a aquifer or acutad or acuclude. Okay.
Sir, you have shown one fence diagram.
Yes.
Uh, what is the tool you used for creating such fence diagram?
I have used mm, that is uh, uh, one software is there. I don't exactly remember that software. That is
And sir, you said one
Rockworks.
software.
Rockworks you can use.
Sir, what is the spelling?
ROCK
Hmm.
WORKS. Rockworks.
And sir, you said about visual mode flow.
Mod flow.
Software.
Visual mod flow.
Sir, it's also freely available. Both the
Ah,
softwares are available.
I cannot say about Rockworks, but Visual Mode Flow it is available. You go to USGS site, means United States Geological Survey. Okay, there you can get.
Okay. Thank you, sir. Thank you very much.
Okay.
You participants, if you have any question, you can ask.
So all PhD scholar, and you are all doing artificial neural network related work or any other work. Means actually you are all belong to, I know, computer science background, but I don't know whether you get an idea of earth science or geology or hydrogeology.
There are few participants from Earth Science and Geology department also.
Okay, okay,
We have variety of participants from computer, IT, geology, and other related branches, sir.
okay. So any question from art science department, they may ask. Any doubt, any questions? Means it is means it should be interactive session, right? Means you nothing to worry. Nobody means it is nothing like that. Okay, somebody knows better than me. How can I ask? It is nothing like that. You can ask question.
Okay, sir. I will start with the conclusion. Thank you, sir, for your very nice and informative session. I hope all the participants learn the concepts of hydrology cycle, the importance of a groundwater, and sir has nicely explained the different types of aquifer approaches to collect the data for analysis and the development of a conceptual model. I hope all of us utilize this for our further work. Thank you, sir, for clarifying such a complex topics in a very simple manner. Thank you, sir, for share your valuable knowledge with us. Thank you, sir.
Thank you, Deepak, and thank you all participating members. Okay.
Thank you, sir. Your participants, attendance link is shared in the chat box. Kindly fill the attendance. Thank you, sir.
Okay. Bye.
Your participants, kindly fill the attendance. It is shared in the chat box.